Have you ever stopped and wondered what single material turns small kingdoms into global powers, built our cities up into the clouds? What is the actual skeleton holding up our modern world? Well, the answer is literally all around you. It's steel. And today, we're going to go on a journey right into the heart of a modern furnace to see exactly how this incredible material gets made. You see, for millennia, civilizations relied on iron, but it had this one fatal flaw. It was brittle. The real breakthrough, the one that changed absolutely everything, was discovering that if you add just a tiny bit of carbon to iron, it transforms into a super material, steel. And suddenly, we had something that was strong, flexible, and ready to build a whole new age. For most of human history, steel was a luxury item, think as expensive as jewelry. But then the 1850s happened, and an inventor named Henry Bessemer came along. His new process made it possible to mass-produce high-quality steel cheaply and quickly. This wasn't just an improvement, no, it was a full-blown revolution. From that point on, steel became the backbone of the industrial age, building the railroads, bridges, and skyscrapers that define our world. Okay, so how do we make this critical material today? While the basic recipe is kind of the same, the kitchen has changed dramatically. So let's meet the star of modern steelmaking, the electric arc furnace, or EAF.
The best way to think of an EAF is as a colossal, high-tech cauldron. It's a massive steel vessel, all lined with heat-resistant materials. And maybe its most impressive feature is that it can tilt. It can rock forward up to 45 degrees to pour out thousands of pounds of liquid steel, kind of like a giant pouring a celestial soup.
So how does the furnace generate that kind of incredible heat? Well, it uses these massive electrode arms. Their whole job is to hold 3 enormous graphite electrodes, lower them into the furnace, and then unleash a current so powerful it creates an arc of electricity. We're talking about a controlled bolt of lightning. The inside of this furnace gets hotter than the surface of the sun. So how do you keep the lid from just melting into a puddle? Through some seriously brilliant engineering. The roof and walls are actually a complex network of pipes that are constantly circulating water. It's an ingenious cooling system that allows the furnace to contain that unimaginable heat without destroying itself. After every single batch of steel, the furnace needs a repair job. A process called fettling or shotcreting is done by a machine just like this one. It's basically a robotic arm that sprays a specialized refractory concrete, a kind of heat-proof cement, onto the furnace's inner walls, patching up any wear and tear. It's like a robotic blacksmith, making sure the furnace is ready for the next fiery round.
All right, we've seen the furnace, our high-tech oven, but what about the ingredients? Let's take a look at the recipe for a modern batch of steel.
And here is the big surprise. The #1 ingredient for new steel in an electric arc furnace isn't raw iron ore, it's old steel. Cars, washing machines, demolished buildings, it all goes right in. This makes the EAF one of the most powerful recycling machines on the entire planet. But scrap isn't just a random pile of junk. Oh no, it's a carefully managed ingredient, all sorted into specific classes. For example, you've got W2 consumer scrap, which might come from old appliances. Then there's W5, which is the super clean blue scrap from factory offcuts. And you even have W11, which are dense bales of pressed wires. Each type is chosen carefully to get a very precise chemical mix in the final steel. Next, you add the spices to perfect the recipe. On the left is pig iron, which is used to adjust the carbon content. That's the very element that turns iron into steel. And on the right are ferroalloys. Think of these as master alloys. They're mixtures of iron with elements like manganese or silicon. They are absolutely crucial for creating specific types of steel with unique properties like extra hardness or rust resistance. The final ingredients are materials like lime and dolomite. When these melt, they form a liquid layer on top of the steel called slag. Now, slag might sound like a waste product, but it's essential. It acts like a sponge, pulling impurities out of the molten steel and creating a protective blanket right over the top. The furnace is ready. The ingredients are loaded. Now it's time to unleash the power of tamed lightning. The process itself is brutally simple in concept. First, a giant basket charges the furnace by dumping in tons of scrap. Second, the electrodes are lowered, the power is flipped on, and that immense electric arc melts everything down. Finally, once the steel is ready, the furnace performs its signature move. It tilts, or taps, to pour out all that liquid metal. But what is actually happening during that meltdown? An electric arc isn't just intense heat. It's an electrical discharge that creates a column of plasma. we are talking temperatures that can exceed 10,000 degrees Fahrenheit. It's this incredible energy that can turn a whole car into liquid in just a few minutes.
But just having a powerful arc isn't enough. You have to use its energy efficiently. And that's where our friend slag comes back into play with a really clever trick. You see, an exposed arc is surprisingly wasteful, losing most of its energy. But if you can make that slag layer foamy and thick, it completely submerges the arc. 93%. By creating a foamy slag, often by injecting carbon, operators can trap the arc's heat and light. This blanket of foam insulates the arc, forcing all of that incredible energy directly down into the steel instead of letting it radiate out and damage the furnace walls. It's a brilliant technique that makes the whole process faster and dramatically more energy efficient. And this technology isn't static. Let's zoom out a bit and see how decades of innovation have made these furnaces not just powerful, but incredibly advanced. The evolution is just stunning. The first-generation furnaces from the early 20th century were slow, taking up to 8 hours for a single melt. They were loud, dirty, and inefficient. Now compare that to a modern fourth-generation EAF. A melt can take under an hour. They're enclosed in soundproof buildings, they have automated controls, they recover waste heat, and they use much safer tapping methods. It is a night and day difference. So when you put it all together, the modern EAF is a true engineering marvel. It's a recycling powerhouse that turns our waste into new resources. It's incredibly energy efficient thanks to some clever physics. It gives operators precision control to create thousands of different steel types. And it accomplishes all this with a much smaller environmental footprint than older methods. You know, we began with steel as the skeleton of modern civilization. And here, inside this furnace, we see that skeleton being melted down and reformed. Every single batch recycles a piece of our past, old cars, old buildings, old machines, to forge the materials for our future. Which really makes you wonder, with this incredible, endlessly recyclable material, what are we going to build next?